A clinical group consisting of patients suffering from knee pain were interviewed. 42% were on pain medication. So we have P of M is 0.42. 65% were doing physical therapy. P of T equals 0.65, T for therapy. 35% were doing both. So we have P of M and T, which is both physical therapy and medication, is 0.35. The question is, what is the probability that a randomly chosen patient does physical therapy knowing that or given that the patient takes pain medication? So P for probability, T for therapy, knowing that, M, which is medication. So in symbols, this is how we write it. P of T given M. So this is what we're trying to figure out. P of therapy, knowing that or given that the person is on pain medication. So if we know that the person is on pain medication, we're trying to find the probability that they're also doing physical therapy. Now, this is how we figure out the formula. We look at the multiplication rule for two events that are not independent of each other. So what is the multiplication rule for events that are not independent of each other? So we have probability of M and T is probability of M and the probability of T. And if they were independent events, we would just stop here. But since the events are not independent, we go given that M occurred. So when we know that M occurred, the probability of T changes. So therefore, we do have to consider the fact that M occurred. So this is the formula, multiplication rule for events M and T that are not independent of each other. Now, remember that if we have to solve for P of T given M, we can divide both sides with P of M. That cancels the P of M out, and we have P of T given M is equal to P of M and T divided by P of M. So this is the formula we're going to use. And I was just trying to show you where this formula comes from, but you don't really need to do all this work if you can remember this. So P of T given M, just remember that it is a quotient. In the denominator sits P of probability of M. So this is after the knowing that symbol. So this sits in the denominator. The probability of that event sits in the denominator. And in the numerator, we have P of T and M. So if I have to find the probability of P of A given B, I need to know that it's first of all a quotient, which means a numerator divided by the denominator. The event that comes after the line, which is the symbol for given that, sits in the denominator, so it's P of B. And then in the numerator, we have P of both. So both would be P of A and B. So this is both. So similarly, we have P of T given M is P of T and M divided by P of M. So this is really P of both, which is given to us, divided by P of M, which is the probability of medication. And that is, probability of both is 0.35 divided by probability of M is 0.42, which is equal to 0.833333. And if the question says, write your final answer with rounded to 2 decimal places or with 2 decimal places, that would be equal to 0.83. So that's the hundredths place, This is a number below 5, so if it's less than 5, we round down and we have 0.83, which is the probability of t given m.